Okay, today's lesson is lesson number 71. We're going to be talking about the standard form equation of a circle. This is the equation that you guys talked about yesterday, right? It looks like this. X minus h squared plus y minus k squared equals r squared. Okay, so we're going to be talking about this and talking more about where it actually comes from. Okay, so it's not just a bunch of random letters and symbols put together. There's a reason why this is exactly the equation of a circle. Okay, so first of all, we have the definition of a circle. This is kind of like a college level definition, I guess. Okay, so not just, oh, it's that round thing, but more specific. Okay, so a circle is the set of points that are a distance r, right? We would think of that like the radius. They're a certain distance away from the center point. Okay, so we will go over to GeoGebra to kind of see what this looks like visually. If you're just watching this at home for the first time, then take a second to write down this definition. Alright, so this is where we're at on GeoGebra. I have a center point, which happens to be 8, 6, and then I have some other point on that's a distance away. So if I want to look at all of the points, I can kind of drag this and it'll give me other points that are the same distance away. And you can see that by doing that it creates a circle. Okay, so one more time, if I keep this distance the same and I want to look at all of the points that are that distance away from my center point, I will get a circle. Okay, so hopefully that definition makes a little bit of sense. Okay, so there's all sorts of different points on this circle. I want to stop right here at 11, 10, just because I see it's a nice clean point that I can use for the calculations we're going to do. So you guys talked yesterday about creating the or sketching a graph based on the equation of a circle. So we know for the equation of a circle we need a center point and a radius. But we don't have a radius here, we just have a center point and a point on the circle. So we're going to think about how we can use that information to find the radius. Okay, so we have, on GeoGebra we had this point A at 8, 6, and then we stopped B when it was 11, 10, and we were trying to find this distance in between. Okay, so in class we thought, hey, we could use the Pythagorean Theorem. We all remember that. A squared plus B squared equals C squared. But we don't really have a triangle here, right? We need to kind of create the triangle. So we're looking for this distance and this distance. We can find those by subtracting the x coordinates and the y coordinates. So the horizontal distance is going to be 3 units because that's how many spaces we have to go over to go from A to B. Okay, and then the vertical distance, we have to go up 4 units, so we could think of it like 10 minus 6 gives us those 4 units. Okay, so plugging in those lengths for A and B gives us 3 squared plus 4 squared equals C squared, which is really just R squared in our case, since the hypotenuse of this right triangle happens to be our radius of the circle that we're talking about. So we can call that r squared. Okay, squaring these gives us 9 plus 16 equals r squared. 9 plus 16 is just 25. And then I can take the square root of both sides to get the radius is 5. Okay, so now that I know the radius and the center point of A, I can create my equation of the circle. So this is just, it's going to go into this form. I know that it's going to be x minus h, which is 8, squared, plus y minus k, which is 6, squared, and that's going to equal 25, which is my radius squared. Okay, I could have also used the distance formula here, which really is what I did. Distance formula is just a fancy version of the Pythagorean Theorem. It's when we have the coordinates like we did here. So when we're talking about the distance between 2 points, we look at the difference of the x-coordinates, just like we did up here. Just like we did right here. And then we square it, okay, like we did over here. So difference of the x's squared. And then we add that to the difference of the y's, which is right here. Difference of the y's squared. Okay, so we're adding it just like we did here. And that's equal to our radius or distance squared. So if we want to just equal to the distance, we would have to take the square root of that whole thing. Okay, so that's our distance formula. Alright, so let's try to derive that standard form of the equation. So thinking about what we did in this last example here, right, we were given the center and a point on the circle, and we were able to find the radius and then use what we know is the standard form of the equation to come up with the equation of that circle. So the point of this lesson was to derive that standard form of the equation. So let's repeat this process that we just did, but instead of having a point of, say, 8, 6 for the center, let's just say A is a general center point, and we'll label it H, K. Okay, and then for a point on the circle, just a general point for B. We don't know exactly what the point is, so let's just call it XY. This will represent any of the points that are a distance of R away from the center. Okay, going back to our definition of a circle, right? It's the set of all points X, Y that are a distance R away from the center H, K. So that distance part is really important in the definition of a circle. So let's use the distance formula that we talked about in the last example to try to create this standard form equation. So if I think that the distance, I'm remembering my distance formula is this, right? I have 2 points, and I know that to get the distance I take the square root of the difference of the x's squared plus the difference of the y's squared. Okay, so for our example here, I'm just going to plug these in using my general point B as my second point and my center A as the first point. So I'll get the square root of x minus h, right? X is the x-coordinate of my second point. H is the x-coordinate of my first point. Okay, so I have that squared. Plus, okay, so plus, I'm going to add to that the difference of my y's. So I'll do the y-coordinate of my second point, which is just y, minus the y-coordinate of my first point, which is just k, and I'm going to square that. Okay, and that gives me this distance between them, which we cleverly can label as r, because that's just the radius of my circle that I'm trying to create. Okay, but that square root can kind of get in the way, so instead of doing the square root, I can square both sides. That will give me r squared is equal to the quantity x minus h squared plus y minus k squared. And that is exactly the standard form of the equation that we learned yesterday. Okay, so hopefully this gives you a better idea of where this equation comes from. Okay, and then in class I had you guys summarize with your partner how we were able to derive that equation, so how we used distance and labeling the points to come up with this standard form equation. Okay, and then we had some independent practice problems, so if you're working on this at home, go ahead and pause and give these a try, and I'll show you the answers in just a second. You wanted to write the standard form equation of the circle given the center and a point on the circle. Okay, so if you do that, you get these as your answers. You can use the distance formula or the Pythagorean Theorem to come up with the radius, and then use the center point for your h and k in the equation. Okay, so this is very similar to some of the problems on your homework, so if you're getting stuck, check your work here. Alright, and that is it for today's lesson. Thank you.